In this lecture, we're going to continue talking about spatial relationships, but we're going to look at distances and nearest neighbors, which is a really common task in spatial analysis. For example, how far is it from the school to the nearest park or the bus stop? What is the closest grocery store to a particular census tract? So let's start by loading in the same data set as we used in the previous lectures. This is exactly the same code as we saw before. We're loading in the pantry data frame from disk, and we're getting our income data from SemPy. For distances, the projection is important, so let's convert both of these data frames to, or geodata frames, to state plane. In California, for Los Angeles, the right zone is 3497, and this is in meters. So how do we find nearest neighbors in geopandas? Well, this is the sjoin nearest function. So we're taking our income data frame, which is the census tracts, and we're going to find the nearest pantry or food bank or similar facility to that census tract. And then there's an optional argument here called distance column. And then this is going to add a column, since we specified it, called dist to pantry, with the distance between the census tract and the nearest pantry. So here it looks like we have a census tract, but we also have all the characteristics of the nearest pantry. So this is a church. Actually, these census tracts, it looks like the same food pantry is the nearest one in all cases. And what's the distance? Well, it's 1,500 meters, 1,100 meters, and so on. So this information is all joined very efficiently in geopandas. So note that these distances are from the closest edge of a census tract to the closest pantry. Sometimes that's what we want. Sometimes we want the distance from the center of a census tract. And this is something we can also do in geopandas by creating centroids. So let's create a copy of a geodata frame with census tracts and income. Let's call it centroids. And let's replace the geometry of that data frame with the centroid of our polygon. What does this look like in practice? Let's create a blank axis object, and let's plot both the centroids and the original census tracts. So we can see here, this is the centroid of this census tract here. This is a centroid of this census tract, and so on. So if we do the nearest neighbor to the centroids, we get, in most cases it seems we get the same result, but the distances here are going to be a little greater. So this is 2,200 meters rather than 1,500 meters. And we can look at the means. So let's look at the mean of this column, our new distance pantry column. If we do a join to the edge of a census tract, the average distance to a food pantry is 1,800 meters. There's 2,700 meters if we look at the distance to the centroids. So getting the closest feature to another set of features is fairly simple using this sjoin nearest function in geopandas. But sometimes you don't care about the closest one, or just about the closest one. But you want to get the distances to perhaps all of the food pantries, or the second or third closest one. An example of when this is useful is in accessibility measurement in transportation. Some measures of accessibility look at the distance to the second closest grocery store, or the third closest grocery store, which provides a measure not just of proximity, but also of choice. Maybe the closest grocery store is something you don't like going to. So to start with, let's look at this for a single tract. So let's extract from the first row the geometry of this census tract and store it in this variable called tract geom. Now let's get the distances from all our pantries to this individual census tract and store them in distances. Let's sort the values so they're in order. So we start with the closest one. So we see that this tract, the closest food pantry is 1,500 meters away. The second closest is 3,300 meters away. The most distant one is more than 100 kilometers away. So because we've sorted these, we can use iloc to get the first or second or third closest one. So the closest one would be iloc 0, second would be iloc 1, the third would be iloc 2. So we're extracting this third distance here, 3952, using iloc 2. So now we see how to do this for one census tract. Let's do this for all of them through a function. So the argument of the function is going to be the geometry of this tract. And we're going to call our function get the third closest dist. So once we get this geometry, we're going to calculate the distances the same way as we did before. To every pantry, we're going to sort them, and we're going to take the third closest. We did this in 2 lines before. We'll just collapse it to a single line. And then this third closest is what we're going to return. So our old friend apply is going to be useful here. We're going to take every geometry of the census tracts, and we're going to use apply to pass it to this function. What's this function? Well, this is the function we just defined. And what's returned? It's the third closest for every census tract. So let's store it in this new column in our income data frame, dist third closest. Finally, let's use seaborn as we did before to plot this. We're going to use our reg plot, which we saw before. Let's plot household income against the distance to the third closest pantry. We see here, again, we get a regression line with a confidence interval, and we get an upward sloping relationship. So the higher income a census tract, the further it is from the third closest food pantry. So these nearest neighbors and distances are really simple to calculate in geopandas. The one gotcha is you always need to watch your projection. Are you using state plane or another locally appropriate projection that gives you accurate distances, areas, or whatever other quantity you're trying to measure?